Alright, so here we are on lesson 4, percent increase and decrease. So this is probably, I think, one of the most applicable things you can learn about percents, because even when you go to the store, you always think about how prices increase and decrease, or what sales do, and things like that. So, in the opening exercise, it says, Cassandra likes jewelry. She has 5 rings in her jewelry box. What percent is represented by the whole collection of the rings? What percent of the collection does each ring represent? So she has 5 rings. 1, 2, 3, 4, 5. And we know all of them would equal 100%. So if we were looking at each one individually, they would be 20%. Okay? And the example 1 says, Cassandra's aunt said she would buy Cassandra another ring for her birthday. If Cassandra gets the ring for her birthday, what will be the percent increase in her ring collection? And we would say that it would be an increase of 20%. All right? So, looking here at exercise 1, this is the important part here on the right side, this percent increase equation. This is our new part for today. But I want you to put over here, write it kind of in your own words. Instead of amount increase, it's just going to be change over original equals, and it's increase or decrease, because you can do both. Okay? So if we look at example A, it says John increased his trading card collection by 5 cards. He originally had 15 cards. What is the percent increase? So we're looking for how much did it change? What's the original? So if we put in our fraction, we know the original was 15 cards. That goes on the bottom. And he added 5 cards, so that was the change that goes on the top. And when you divide those, you get 0.3 repeating. So to make it a percent, we'd have to move the decimal twice, so we would get 33.3 repeating percent, and this is an increase. Right? Example B says, suppose instead of increasing the collection by 5 cards, John increased his 15 card collection by just 1 card. So we still have our 15 cards, but just by 1 now. And then will the percent increase be the same as when Cassandra's ring collection increased by 1? Explain why or why not. So our blank fraction here, the original was 15. He added 1. When you divide that, you get 0.06 repeating. So this would be a 6.6 repeating percent increase. Alright, so again, you're pretty much just reading the question and plugging in the right spot and then dividing. Alright, so go ahead and flip over to the next page. Example 2, same thing here. It says, Ken said that he is going to reduce, that's an important word, the number of calories that he eats during the day. Ken's trainer asked him to start off small and reduce the number of calories by no more than 7%. Ken estimated and consumed 2,200 calories per day instead of his normal 2,500 calories per day until his next visit with the trainer. Did Ken reduce his calorie intake by 7%? So, the thing with this question is, if we were to set it up, we know our original is 2,500. They didn't give us the change, so we're going to have to calculate it, but it's a pretty simple calculation. We take that original 2,500 minus what he had been eating, which was 2,200. So that change would then be 300. That's what goes on top here. When you divide those, you get 0.12. So that means this would be a 12%, and it's a decrease. So to answer the question, we would say no, because he reduced his calorie intake by 12%. So we can say he reduced his calorie intake by 12%. Alright? So you have to be careful that you don't just put down the new number, you have to calculate the change. Alright, we're going to skip exercise 2 for right now. And we're going to go on to page 11 in your notes. And we have example 3 here at the top. And it says, Justin earned 8 badges in Scouts as of the Scoutmaster's last report. So I'm going to underline 8 badges. Justin wants to complete 2 more badges so that he will have a total of 10 badges earned before the Scoutmaster's next report. If Justin completes the additional 2 badges, what will the percent increase in badges be? So again, we have our blank one. We know originally he had 8. We're trying to find that change. So if he goes from 8 to 10, we subtract, that change would be 2. When you divide that, you get 0.25. So it would be a 25% increase in badges. Right? B says express the 10 badges as a percent of the 8 badges. So this is going back to what we did before. So we see that keyword of the 8 badges. That means this is our whole. The 10 badges is our part. So I'm going to use our equation. So it's 10 equals x for our percent times 8. And if we divide by 8 on both sides, we get x equals 1.25. So as a percent, that would be 125%. C says, does 100% plus your answer in part A equal your answer in part B? Why or why not? And if we look at, it would be 100 plus that 25, so we could say yes. And it was the total plus the increase. Okay. So moving on to example 4 here. It says, example 4, finding the original amount. So now we're looking for that original amount given the percent increase or decrease. So this is going to be a little different setup. It says the population of cats in a rural neighborhood has declined, that's important, in the past year by roughly 30%. Residents hypothesize that this is due to wild coyotes preying on the cats. The current cat population in the neighborhood is estimated to be 12. Approximately how many cats were there originally? Alright, so this is going to be a little bit of a different setup, alright, because we don't know that whole, that original number. Alright, so first here we need to label our part and our whole. Our 12 here is going to be our part, and our original is our whole number. Alright, so a note I want you to write to yourself here is that when finding the original, you need to add or subtract 100, like 100%. Okay? So it declined in the past year by 30%. So that means we're going to do 100 minus 30 to get that 70%. Right? And this 70% goes with the whole portion that we're looking for. So we're going to go back to our original setups, either the equation or the proportion. If we set up our equation, our part is 12 equals our percent, which is 0.7 times x. If we do it the other way with our proportion, then we have 70 over 100. We have our part, which is 12, over x. Alright, I'm going to solve the equation just because it'll be faster. Divide by 0.70. And we get 17.14 equals x. Of course, we can't have 17.14 cats. So we're going to have to round it down. And we would say that there were about 17 cats originally. Alright, and if you think about that, that does make sense, because if it decreased by 30%, we went from 17 down to 12, so that is a good way to check and make sure if your answer even makes sense. Alright, let's see, we have one more on the back, but we're going to skip this one for now, and we're going to just do this in class. Okay, so if you have any questions, just bring them to class tomorrow, and then we'll do this last example all together in class.